Hello, my name is Beth Dixon, and this is a video presentation on Vicki Borlaug's PowerPoint presentation on hypothesis testing for the mean. And this is a summary video on hypothesis testing, and it's based on a PowerPoint by Vicki Borlaug. For this video, we are assuming that x is normally distributed and sigma is unknown and estimated with the sample standard deviation s. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to make this video. In our first case, we're testing the claim that the mean mu is less than mu sub 0. And the mean mu, meaning the population mean, is less than mu sub 0, where mu sub 0 is a particular number given to us in our particular problem. In other words, it's an actual number that we have in our problem. And since we're not dealing with an actual example, we will designate it with the variable mu with a little 0 as a subscript. In this case, since we're testing the claim that it is less than, this is a left-hand test. And since it is less than, and that does not contain the condition of inequality, or excuse me, that does not contain the condition of equality, let me say that again since I said it wrong, since less than is not a condition with equals with it, that is the alternate hypothesis h sub 1, and we put that there in h sub 1, the alternate hypothesis, that the mean is less than whatever that particular value is, mu sub 0. So we have the mu is less than mu sub 0. That then means that our null hypothesis is that the mean mu is greater than mu sub 0, or excuse me, that the mu is greater than or equal to mu sub 0. Apparently I'm tongue-tied today because this is take 2 of this video. So we have the null hypothesis that the mu is greater than or equal to mu sub 0, and that the alternate is that the mu is less than mu sub 0. To draw our graph is the next step, and remember that we always graph and place our alpha significance level, or our alpha risk, as the alternate hypothesis, and that is a less than, so that will be a left-tailed test. I keep it straight because it points to the left. It's less than, and we shade it to the left, less, and that alliteration helps me to remember that less and left both shade to the left. To find our t-statistic, we use the formula t equals x bar minus the mean, or mu sub 0, which is that number that we're comparing it to the population 2, divided by s divided by the square root of n, and that is our formula for our t-statistic. If h sub 0 is true, then it would be unusual to get a t-value in that left tail. If the t-value is in the left tail, because it's unusual, we would reject h sub 0. So that means anything here indicated in the red area would be a reject HO. Otherwise, we would not reject HO. So the area to the right is do not reject, and the area to the left is reject. Our second scenario is to test the claim that the mean mu is greater than mu sub 0. This is a right-hand test. Greater than does not contain the condition of equality. Therefore, we have mu greater than mu sub 0. Again, remember that mu sub 0 is just a particular number given in the problem. Since mu is greater than mu sub 0, Our null hypothesis is the complete opposite of that, which would be that the mu is less than or equal to mu sub 0. So mu, opposite of greater than, would be less than or equal to. Please remember, as an aside here, that some teachers just use the equal to part in your null hypothesis, and that therefore will not use the inequalities there, and will just put the equal to. Either way is equivalent for what we're doing. We are now ready to look at the graph, and in this graph, since we are looking at the alternate that is greater than, which means greater than shades to the right. I look at it this way: it points to the right, we shade to the right. Our t-statistic formula is the same, so I won't read it again. It's there in front of you if you need it. And we have, if HO is true, then it would be unusual to get a t-value in the right tail. If the t-value is in the right tail, then we would reject H sub 0, because it would be unusual to have a t-value in the shaded region. We would reject HO if it's in the shaded region. Otherwise, we would do not reject HO, and those would be the area to the left. The third scenario is where we would test the claim that the mean mu differs from mu sub 0. Again, remembering mu sub 0 is a number from our problem. This is a two-tailed test. A two-tailed test, since this is differs from, and remember differs from is indicated by the mu not equaling mu sub 0. Again, because it doesn't contain the condition of equality, that means it's going into the alternate hypothesis. And that means that our null hypothesis is that the mean is equal to mu sub 0, or mu is equal to mu sub 0. I'm bad to say mean as opposed to mu. For my purposes, they are the same. X bar also means the mean, but that's the sample mean. To graph this, we look at the alternate hypothesis, and since this is a not equal to, that makes it a two-tailed test. Notice as we do the two-tailed test that we divide our alpha risk or significance level into two equal parts and put the parts equally in both tails. Our t-statistic formula is the same. T equals X bar, our sample mean, minus mu sub 0 divided by S divided by the square root of N. If H sub 0 is true, then it would be unusual to get a t-value in the tails. So if the t-value is in the tails, then we would reject H sub 0. Notice we have two tails, therefore we will have two reject sub H0 regions, one for each tail, one on the left tail and one on the right tail. That leaves us a region in the center for our do not reject H0. So in the center we have do not reject, and each tail is a reject H sub 0, or to reject the null. This is a quick summary and overview of the three types of hypothesis testing: left, right, and two-tailed testing. For further examples and detailed examples, please see the other videos on hypothesis testing that I have completed. Again, thanks for watching.